So hi everyone, you can see this is the apparatus for the study of half wave, full wave, bridge rectifier and filters trainer. So first we should know what is rectifier. Okay. So rectifier is a circuit which converts the alternating current input power into a direct current output power. The input power supply may be either a single phase or multi-phase supply, with the simplest of all the rectifier circuits being that of the half-wave rectifier. In this apparatus, we can see the 2 voltmeters and 1 ammeter. So one is for AC measurement, AC voltage, and this is for measurement of DC voltage, and this is the DC current in terms of milliampere. And here we have 2 diodes, so we can select here the values, and this is the inductor of 200 millihenry, and this is the capacitor of 1000 microfarad, and here we can select the load resistance from 50 to 10k ohm, and here AC power supply. We should know the definition for half wave rectifier. In this diagram you can see here the AC waveform. Here the power diode in a half wave rectifier circuit passes just one half of each complete sine wave of AC supply in order to convert it into DC supply. Then this type of circuit we call it as a half wave rectifier, because it passes only half of the incoming AC power supply as shown in this diagram. This is the complete AC waveform. When it passes from the diode, the DC, it has been converted into DC supply by giving the output as half wave. So if the positive half cycle if we are dealing with, then the diode is in the forward bias. If we come across the negative half cycle of the AC sinusoidal wave, then we are going to deal with the diode in reverse bias. Formula to calculate the DC voltage, V maximum divided by pi, that is 0.318 V max, 0.45 saturated voltage. So V max is the maximum or peak voltage of the AC sinusoidal supply, and Vs is the RMS root mean squared value of the supply. So this is positive half cycle, that is diode is in forward bias. Here is the circuit diagram for half wave rectifier. Let us make the connection. Verify here. This 12 volt battery is connected to the voltmeter, selecting the diode, and we have to connect this AC voltmeter positive negative terminal to the 0 to 12 volt. Okay, this is for AC voltmeter connection. Next here we have to connect DC voltmeter and AC ammeter. So here first we have to connect the DC voltmeter to these two terminals and AC ammeter to these two terminals. Here is the common junction. First we should connect here AC power supply of 12 volt. So here I am going to select 12 volt and I will connect it to voltmeter, AC voltmeter, and then this common connection we have to make it to the diode. We have to select. Then this diode must be connected to voltmeter. Then we have to connect this one to the 0 volt. 0 to 12 volt we are selecting the AC voltage to measure. So next we have to connect here the DC voltmeter to the voltmeter here, and then negative terminal of this DC voltmeter to negative terminal of this voltmeter. Next we have to connect DC ammeter to milliammeter here, this one. Okay, next positive terminal we should connect here, positive terminal of the DC ammeter. Connect this common terminal for DC voltmeter and DC ammeter. Okay, so we have connected AC voltmeter, DC voltmeter and DC ammeter. So let us switch on the device here. So we can observe the variation in the AC and DC voltmeter and as well as in the ammeter, milliammeter. So next what we can do here, press the switch S1. We can see here two switches they have provided. So switch S1, if we press switch S1, we can observe the changes in the values of voltmeter as well as ammeter. So the value has been increased. Once again we can check here. So this AC voltage is quite same. DC voltage and current has changed. So they have increased. So next there is one more switch here, S2. Let us press this switch S2 and observe the result here. So it has not made much effect here, only the current has increased. Then here the load resistance they have given, we can select the load resistance and we can observe the changes in the voltage and current. So voltage is increasing, current is decreasing. According to Ohm's law, voltage is directly proportional to resistance but current is inversely. So that's why current is decreasing but voltage reading is increasing. So that means this is the connection is quite good for the half wave rectifier. So you can see here I have applied right now nearly 1k ohm. The voltage is 15 volt, current is less than 50 milliampere. So last 10k ohm when I apply, current becomes 0 minimum and the voltage is about 17 volt. So that means this is the connection is made correct for half wave rectifier. The tabular column we should note down AC input voltage. Okay, because it is reading 12 volt, we have applied the input of 12 volt. Then output voltage, corresponding output voltage you should note down. This is DC voltage. So next we have to note down here output voltage when S1 is on and output voltage when S2 is on. So these are the switches they have provided and you can note down the values of output voltage for both the changes in switch, and you can also observe the changes by applying load resistance.